There's a couple of things we can consider when dealing with epoxy powder applications on the copper bus bar. You definitely want to use full round edge bar if possible, or you have to kind of manually create those rounded edges on material that may not be from the factory. On square edge material, the epoxy kind of thins out on the edges, so you don't get the same material thickness of the epoxy on a square edge versus a round edge. On a round edge, you of course have more surface area for the epoxy to build the proper thickness. So you get a lot more consistency in your coverage on the edges. A lot of times we'll see drawings that are dimensioned to the epoxy, and it kind of creates some confusion. Sometimes you have to create two drawings. You have to create a preliminary drawing of just the copper before powder, then have a supplemented drawing that has more of the dimensions just for the masking areas and where the powder starts and all that stuff. The powder will want to run away from the edges, so if you've got sharp corners, you're going to have a lot thinner coating on the corners than you will if you had a large radius around those corners. So you definitely want a generous radius on all the corners and edges of your bus bar, so you can again build a consistent powder coat thickness around those edges. When you're powder coating the inside of your hose, if you have hose sizes that do require insulating epoxy, you definitely want to do some type of countersinking or some type of edge conditioning to your hose. Those areas are a high risk area to pass high pot testing. And due to the fact that you could be punching those holes, you may be drilling those holes, you may be doing a lot of different manufacturing methods to put that hole in the part, you want to make sure that you deburr the hole properly and countersink both sides. Do whatever you can to reduce the amount of sharp corners around the hole. Another thing you got to really worry about is what hole size to use, okay? Because definitely the hole size is going to be reduced by the amount of powder that you apply to the part. And if you get into really small diameter holes, those can actually almost close up. So you want to make sure that you're keeping your hole sizes maybe 1.5 to 2 times the diameter of your thickness of your bar. And sometimes you may have to do some testing or whatnot to ensure that your powder thickness is not going to get to a small enough area where it causes an interference with the hole size clearance. The two types of applications to apply the powder are typically your electrostatic spray or your fluidizing. And really what dictates which one you use a lot of times is just basic powder thickness requirements. So for low voltage, we call low voltage around the 10 to 20 mil coverage. That's usually anywhere from 600 volt requirements up to maybe 1,000, 2,000 volt requirements. We'll put 10 to 20 mils on that material electrostatic spray, so we'll hang parts on the racks and get a mask, and we'll go through and use that process. As we go into medium voltage requirements, the powder thickness increases drastically. So you have a call out now of minimums of 50 to 120 mils of coverage. So you can't really spray that much onto the bar. So you have to use the fluidizing process, which is more preheating your bar and actually dipping it into a fluid tank of the powder. When you're fluidizing, it's very important that your edge conditions are to the guidelines that we spoke on previous. I mean, when you're testing to 5 kV, 15, and 35, any kind of a square corner or whatnot is going to give you a lot of trouble when you're trying to pass those type of higher levels of electrical testing.